Okay, one quick thing that I want to mention about monomials is also that you can apply the power properties to monomials. Okay, how does this work? Well, as you remember, if we have, say, for example, m squared to the second power, like this, m squared squared, right? Then what happens is that we multiply the two powers, right? So it becomes m times 2, which is equal to m to the fourth power. Easy enough, right? Well, if you have a monomial like this whole thing squared, okay, what you're going to do is you're going to distribute, okay, this power to the variable and also to the number. So be careful when you do this, not to go 2 times 2. Alright, well in this case 2 times 2, 2 squared, same thing. But if you had a different number, it wouldn't be the same. So for example, if we had, like 3 and then squared, it's not saying 3 times 2, right? It's saying 3 squared. 3 squared is 3 times 3. Much different than 3 times 2, okay? So watch out for that. So here, okay, let's go back to here. It's going to be 2 squared. Squared. Be careful, okay? So it's going to be 2 squared. And then we use the same power properties here where we have m and then 2 times 2, which is 4. Okay, we can continue on here, can't we? What's 2 squared? 2 squared is 4, m to the fourth power. Okay? Let's try another one. Now let's try one where we have 2 variables and also a coefficient. So let's choose, how about 3, okay? And then we have m to the fourth and n. Well, let's be adventurous here. Let's have n to the negative 2, okay? Alright, this isn't impossible. You could probably have this. Alright, and everything is going to be cubed. Okay, how would you use this problem? Again, we're going to distribute to each term, right? So to the number, to m and n. So it's going to be 3 to the third power, not 3 times 3, but 3 to the third power times m, and then 4 times 3 is 12, and then n, which is going to be negative 2 times 3. Negative 2 times 3 is negative 6, n to the negative 6, n to the 12, right? Alright, are we done here? Not quite. We can, alright, expand this, right? So 3 cubed is 3 times 3 times 3, right? So what's 3 times 3? That's 9. What's 9 times 3? That's 27. So the final answer is going to be 27. Okay? m12 to the n to the minus 6. Okay? Sometimes they'll probably want this in a fraction form. So let's look at n to the minus 6 here. Okay? Remember we said if we have negative powers, what does that represent? It represents a fraction, right? So the final answer is going to be 27 m12, right, to the 12th power over, so that's going to be n to the 6th power. Because remember, n to the negative 6 is equal to 1 over n to the negative, n to the 6, sorry. Alright? So that's why, alright, this n to the 6 is in the denominator. Alright, and 27 and m12 is in the top. Because these are positive. Well, 27, that's just a number, so it's going to be at the top. Alright, m to the 12th power, that's positive, right? That's not negative power, so that's going to be on the top. But if you have negative, it's going to be on the bottom.